Thank you, Beth. Gosh, what a beautiful campus. Driving in this morning, I live in Issaquah, and I just don't get out to campus enough. Gorgeous campus and beautiful event. Thank you, Beth and Moran, for having me. We're really looking forward to engaging with you all. What a time to be starting a career in aerospace. This is an unprecedented, I think, moment in history. Just what a time to be alive in general. Like Beth said, I'm the Director of Engineering for Urban Air Mobility at Boeing, and I'm going to talk about, actually we're all going to talk for the whole day about the future, about what's possible in aerospace and what we can do to make it safer, cleaner, and better connected. And I'm going to spend time talking about the beginnings of this novel urban air mobility industry, advanced air mobility industry, and I hope it captures your imagination. I think the speaker lineup today is pretty fantastic across the entire spectrum of aerospace. But before we get into it, I want to share with you a bit of a personal reflection that I had recently. This is during COVID with my family. I have 3 kids. This is my daughter, Amelia. She's 8 now, but she was 7 in this picture. And we were walking through the Museum of Flight here in Seattle during COVID, and had a bit of an epiphany walking through the early days of aerospace, and realized, geez, the first several decades of aerospace was incredibly innovative. The rate of innovation, and my children, 5 and 7 at the time, noticed it by saying, "Wow, look at all of these different airplanes." As we're walking through the earlier decades, look at how many different types of airplanes there are. And so we did a little bit of a game. I want to do it with you too, because I think it's a reflection of what we're about to feel again. Imagine you were 7 years old. Let's take Amelia, for example. We said, Amelia, imagine you're 7 years old when the first flight happened in aviation. The Wright brothers' first flight happened. That's old enough to remember, as you get older, the magic of flight and that whole event being just really special. A human being flying like a bird in the newspapers, and it was just about the magic of flight. But young enough to have your entire life ahead of you and seeing that rate of innovation. So in her lifetime, she would have seen, as she got a little older, the practical applications of aviation start to take place. Start to manifest, and beyond air shows, it started to look like, okay, we can use airplanes for mail. And then the world wars happened, and the role that airplanes played in the world wars and how that accelerated innovation. That would have taken her into her early adulthood. And then eventually she would have gotten to, in her adulthood, where airplanes now are starting to be used for human travel. And then the jet age. Her kids might have been older by the time she was old enough to afford like a cross-continental or an intercontinental flight, but she would have experienced that on a jet or a fast piston airplane. And could you imagine the feeling of what Amelia would have felt looking down at the ground, traveling 400, 500 miles an hour for the first time, going from hundreds and hundreds of miles, maybe over 1,000 miles in just mere hours, where in her childhood, literally the way you would travel is on bumpy, muddy, rocky roads, and the idea of crossing the country on road wasn't even fathomable. It wasn't like it would take you weeks or months if you ever did it at all. But here she is now in her lifetime, able to connect to the parts of the world that she might not have imagined as a child is even possible. I think that moment would have been incredibly moving. I think looking down and just having that thought would have been a very moving experience for the human, just for society in general. But then she would have seen amazing things happen still within her lifetime, breaking the sound barrier, going to space. She would have watched in her 70s, this is 1969, she would have watched a human being leave Earth and land on the moon and come back. Maybe you watched that with her grandkids on TV. That would have been a life experience for somebody that was 7 years old when first flight happened, all in a single lifetime. I mean, if you just imagine, that sends shivers up my spine how amazingly fast we're able to innovate. Now, since the 70s, we as an aerospace community, and especially on the commercial side, we've had a significant focus less on revolutionary products. A lot of the revolutionary products happened upstream of the 70s, but from the 70s until today, it's been a strong focus on safety, reliability, efficiency, and we created this enormous system, an infrastructure that transports 4.3 billion passengers a year, 46 million flights a year to move people around the world. I mean, just think about that scale. And then the safety system we have in place and just an impeccable safety record for that number of people moving around Earth. And that is an important thing to remember, because that theme of safety, that is now a foundation that we all have a responsibility to maintain. That's society's expectation. When we get on an airplane today and we go across the country, the first thing we worry about is when the Wi-Fi is going to be turned on. We don't think about our life being in danger because it's just not a thing. I need an aisle seat, I need a window seat, I need a Wi-Fi. You know, I think that in and of itself is an amazing achievement. And that firm foundation of safety is going to be a theme throughout my talk. The flying public expects it. But even still, with that massive scale, only 20% of the global population has experienced the joy of flight. So where are we today? Now, Amelia is 8 years old today. And I believe, like Beth said, we're on the cusp of this innovation rate change that brings all of the engineering disciplines together. I think you introduced it really well. In a whole new way. It used to be like, hey, I'm going to go into airplanes, I got to study aerodynamics, and we got recently into electrical engineering, mechanical engineering coming together. But now it's really blending with tech and automotive and all of these industries coming together in this really amazing way. This convergence that's happening, that's enabling this, is really a few key things. Societal norms are changing. Our expectation as a society, the way we adopt technologies, the way we adopt change as a society is evolving very quickly. Look at JCATI and AI. I mean, that was introduced in November. We broke it 3 months later as a society. We overwhelmed it in 3 months. It took years for Google to achieve that a couple decades ago. So the rate of societal acceptance of change that's different. Business models have taught us that on-demand services is a very lucrative business model, and it's kind of Uber and Lyft business models have changed how we think of things. I don't think before Uber and Lyft became a thing, I don't think we would have imagined one day we would basically be hitchhiking with our phones in strangers' cars. But that's kind of what we're doing. It's just tech has enabled that, and it's become a whole business model. And of course, then technology. I mean, the technology now, convergence, through electrification, our digital infrastructure, and autonomy, is enabling what we're seeing now in this wave of new technology. Electrification allows us, we've seen this in automotive, to really simplify aircraft design. And it puts us on a path from a sustainability perspective on our goal to 2050 of net zero carbon emissions in aviation. The digital infrastructure, we know we've got a transformation in work for future airspace management. And also the digital world is transforming how we develop new products. And the connectivity and the ability to really increase the level of rigor through strong digital connections of our engineering practices. And of course, autonomy, which I believe is the key to unlocking what I call Aviation 3.0. And I think when you zoom out in aerospace history, you'll see a couple significant events. The jet age, first flight. I think when autonomy becomes a commercially certified thing, that's going to be on that same scale of a small handful of incredible aviation milestones. And I think we're on the cusp of this. That's going to just open up the window for a whole new, the next 100 years of aviation. It's just going to change the operational viability and the whole economics around aerospace. So, like I said, Amelia is 8 today. I think the change she's going to see in her lifetime, we haven't even imagined. And I don't think every generation has that opportunity. And all of us here in the room are going to get to experience that. I was talking to the cool table up here in the front this morning, and we were just reflecting on how special that is to be entering a career, and how rare, we can't take that for granted. I don't think it's been this much innovation happening at once since probably the 50s and 60s of people entering their careers in aerospace. So it's that special. Okay, let's get into it. So it's predicted that 70% of the global population is going to live in big cities by 2050. And if you felt the impacts of congested urban environments, you can imagine that's just going to get worse unless we do something about it. We got to come up with creative solutions. And this is the compelling problem statement, really, that's drawing so many people into this idea of advanced air mobility or urban air mobility. The convergence that I talked about is allowing us to think about air transportation now, not just intercity or intercontinent, but intracity, within the city. How can we use airplanes? And it's just like we've all fantasized being stuck in traffic. Geez, I wish I could just, elevate my car and fly over this traffic jam. But I think that fantasy has some realistic opportunity here in the near future. And there's also a long-term benefit to decongesting the roads from a sustainability perspective. 20% of global emissions are from transportation. A majority of that is ground transportation. So in addition to that, as you know, aviation is also grappling with the responsibility of reducing carbon emissions. So all of this kind of blends together. And Boeing is looking at advanced technologies beyond electrification as well, like fuel sources and other technologies that will enable this infrastructure. So we're making long-term investments to explore and mature these technologies. What I want to talk about, though, as a key enabler here is autonomy. I think it's a critical enabler. And like I said, I think it enables Aviation 3.0. We have a long history of autonomy at Boeing and in aviation, where we've removed the pilot from the cockpit. Airplanes without onboard pilots have been around since like World War II, and we stand on the shoulders of those ahead of us because we've learned a lot from them. Since World War II, there's been many applications or missions in defense where it's not feasible to put a human or safely carry a pilot. So we've had to come up with solutions to that. And also, we've been very curious about it and invested quite a bit of research in autonomy. And we've learned some important things through this. And one of the things I'm failing at right now in this talk is I talk about autonomy very generically. In fact, on our engineering team, we have a coin jar. We don't use the word autonomy as a generic statement. It's too broad. It doesn't mean anything. We got to get more specific. Autonomy is not a box that's just bolted onto an aircraft and say, okay, here you go, you have an autonomy now. It's really, within the context of autonomy, it's not an isolated solution. It's fundamentally comprised of a set of functions, from flight control laws to detect and avoid functions, through perception sensors and behavior algorithms. That's where the contingency management engineering comes into play, and you get really specific in each of these functions. But most importantly, I think the thing we all have to realize is that the human in these scenarios doesn't go away. There's still a human in the loop. They're just doing different things. In all of these cases, and even in the case I'm talking about today, and because the human's on the ground now, it requires a very robust communications, data links, and robust cybersecurity. And I think we're going to hear a little bit about that from about Starlink later today. So I want to show you, this is a video here. Today's technologies, I think, have evolved quite a bit that demonstrate these capabilities. This is Boeing's MQ-28. It's called the Ghost Bat, or Air Teaming System. It's developed by our team in Australia, and this basically is an autonomous wingman for fighter jets that takes missions that aren't feasible for humans to go into. It's stealth. It's got a multi-role capacity. It basically has the nose is a modular mission package. You can replace it with different mission packages. Pretty cool. There's a very similar aircraft called the MQ-25 that's basically an autonomous tanker, aerial refueling. And that aircraft, the autonomy system on that aircraft is amazing because it has to operate in the world's most severe environments, harshest conditions. It literally lands and takes off on aircraft carriers on its own. And so those technologies are actually, they're done. We're building it right now. In the commercial sense, when we think about commercial airplanes, think about this: 90% of the pilot functions on airlines today are performed by a computer. Over 90%. Automation is part of what we've been doing in aviation for decades. It's how we're making it safer and reliable. And automation is really, that's the point, is to make it safer. So we can leverage all this history and take that same technology to create a commercial aircraft capable of autonomous flight that navigates a safe, predictable, reliable path every time. And we're basically setting up a system where a human being can monitor multiple aircraft at once on the ground. So Boeing is pursuing, maybe you don't know this, but we've actually got a couple of joint ventures. You might have heard of Wisk or SkyGrid that we're very deeply involved with to enable this technology. This isn't a singular solution. You can't do this just through the aircraft. You have to look at it as a system of systems. And I believe that certification now, making this commercial, changes everything. So to enable these commercial autonomous operations, we've got to look at it from both aspects, the infrastructure and the aircraft. And we're looking at how these functions really span across both. The certification of these functions and this capability has to be done at the absolute highest rigor, the highest safety rigor. See previous conversation. With SkyGrid, this is our joint venture with Spark Cognition, a leading software development firm. We began basically years ago, 2018 timeframe, by developing a use-based service provider solutions for small UAS. That's essentially drones. And right now, SkyGrid's powering thousands of flights for small UAS, that's low altitude airspace integration, helps pilots basically safely, legally, efficiently fly their drones. But what we're trying to do with SkyGrid now, what we are doing, is evolving to expand into the advanced air mobility category. And the next step for SkyGrid really is to become the world's most trusted provider of autonomous functions that integrate uncrewed aircraft into the crewed airspace. With Wisk, that's our joint venture with Kitty Hawk, Google's Kitty Hawk. We're developing the world's first all-electric, 4-passenger autonomous aircraft. And the thing that attracted us to Wisk is Wisk's commitment to this, safety through autonomy and looking for the safest scalable solution in this urban air mobility. Wisk is not in a race to be first to market. It's applying all of its energy into creating the safest scalable solution for the industry, and together with Boeing, we're setting those standards and what that looks like. So this is a video of the 5th generation Wisk aircraft. The incredible engineering team at Wisk, a relatively small company, has been iterating their design over the last decade and over 5 iterations. And they've been committed to enabling everyday flight for everyone through their mission. And throughout their journey, they've had a relentless commitment to safety through a safety management system that spans across the entire design process for the vehicle itself, production system, operations, et cetera. And that's all built into the design of what we intend to certify. This is one of 1,600 plus flight tests that Wisk has conducted. And our intent really with our strategic partnership between Boeing and Wisk is to combine the best of aerospace startup agility, a Silicon Valley startup company, with Boeing's expertise, vast expertise, to go beyond the prototypes and commercialize this next great leap in aviation. This is Gen 6. This is the model that Wisk intends to certify and produce at scale for commercial autonomous passenger carrying operations. It's a four-passenger aircraft. It's self-flying, all-electric, vertical takeoff and landing. It cruises between 2,500 and 4,000 feet AGL, a range of 90 miles with reserves. It cruises at about 120 knots. The 6 forward fans there tilt to transition from vertical to horizontal flight. And the high wing allows easy access, entry and egress for the passengers. Being battery electric, that means there's many fewer parts. There's no hydraulics, no oil, no fuel. So that improves the reliability, safety, stability, and frankly, the passenger experience. Also reduces the noise footprint, which is a very important thing if we're considering urban environments. So this is Gen 6. I'll show you a picture of the inside too, because a lot of people are curious about that. It is a bit surreal to get inside this aircraft and there's no pilot controls. You know, it kind of feels weird. You have an in-flight display and you have an ability to talk to your ground support for basically your flight attendant on the ground, and they'll help you through all of the ingress, egress, and the safety and the route. There's just a human on the other side, so it makes it more comfortable. Large cabin, very roomy, and actually one of the things I really admire about Wisk is from day one, they're designing this aircraft to be accessible to everyone. So they're considering disabilities and ways that you should be able to ingress and egress and have a comfortable flight. And of course, the accessibility from a price point perspective too. That's an important part to be accessible from an affordability perspective. All right, like I said, the type certification of the aircraft alone is not sufficient. So to introduce uncrewed aircraft into the national airspace, we have to look at all the onboard and offboard systems. So we're going to achieve the type cert, of course, but we also have to achieve operational certification and pilot training certification. So the entire system is going to be touched here. So let's look at some of the key elements that we need to address. We need to have reliable and redundant command and control links that comlink to the ground. We need to have vertiport standards and infrastructure. The operating picture with the digital services have to be available to the multi-vehicle supervisors that are monitoring these flights. That includes the air traffic management data, weather, obstacles, vertiport data, etc. For this to be a very reliable and redundant travel trajectory, there's something called 4D trajectory, which is time-based deconfliction. It reduces the load on ATC because you know where the aircraft's going to be when from takeoff. That's all built into the beginning. And then we got to recognize that the air traffic management system is going through modernization efforts to increase tactical conflict management in this segment of airspace management and others as well, and up at higher altitudes in different airspaces. This is a picture from a document that Wisk and Boeing co-published last year. That's essentially the concept of operations for autonomous urban air mobility. And this snapshot documents the actors for the concept. If you stare at it long enough, your imagination will suck you in and you start to think about all the different elements of it. But basically this paper we wrote, there's 2 versions of it. That QR code works, by the way, if you wanted to download it. There's two versions. There's a summary version, which is very graphical. It's about 10 pages. And then there's a detailed engineering concept description, which is 66 pages long. And we basically describe a phased and a pragmatic approach to enabling autonomous operations as the safest scalable solution. And we discuss the levels of certainty through deterministic automation, where humans remain in the loop all the way throughout. We made this public because it's important for the entire industry to align, especially domestically, on the sequence of airspace integration methods. What needs to happen first? We could solve this problem many different ways, but if we're pulling in the same direction, the likelihood of this happening is it goes way up on the timeline we all desire. So feel free to download a copy. There's an email address in that to accept your feedback if you have any thoughts or ideas for us as well. All right, I want to bring it back to the responsibility that this entire industry shares to maintain the highest level of rigor and safety. I think it's important that we all share, and I actually believe this is quite respected. I go to a lot of these events where I feel it. We all recognize the importance of this responsibility, that it's a common and heavy burden. Bringing everyday flight to everybody in an intracity capacity is going to capture the human imagination like we've never seen before. And that means there's going to be a lot of new and innovative ideas coming out there. With that comes significant risk. In an event involving one of these aircraft in an urban environment, I think the entire new industry will feel the consequence. The public won't differentiate. Oftentimes I'm asked about public adoption. Like, are you worried about people wanting to take this from the get-go? And actually, I'm not worried about public adoption. I think our society has plenty of early adopters. I think there will be lines around the block when this is first introduced. What I'm worried about is what happens after the first incident that could set the entire industry back. And like I said, the watching public won't treat it like a car crash. So we believe that commercial operations in densely populated areas at scale will require meeting or exceeding an equivalent level of safety to today's commercial air transportation system. That means it must be as safe to get on an electric air taxi as it is to hop on an airline flight. So as pioneers of this, we've made a very aggressive commitment to safety, and that has to be built in from the very early design phase of the aircraft, all the way through certification. This is a high bar. And not a small commitment. So that's why the partnership here between WISC and Boeing is so valuable. We're in it to set that bar. But that's how we create Aviation 3.0. I'll close with this quote from Bill Boeing. And I think it's as relevant today as it was 100 years ago. Boeing is committed to innovation, and I'm really fired up about the path we're on. I believe it will change mobility for humanity. So I'm going to read it out loud because I think it's really special. Our job is to keep everlastingly at research and experiment, to adapt our laboratories to production as soon as practicable, to let no new improvement in flying and flying equipment pass us by. What a special quote. All of us are here with a role to play as we shape our future. And as we will hear from many today, including the wonderful projects in the back here, innovation in aerospace is bursting right now. And I just want to say congratulations on those of you starting your career at It's Like You Won the Lottery. I think this is a really, really special time. I'm looking forward to seeing what you'll build.